I think we can start. I would like to invite Scott Hansen on the floor. I don't know, Scott, are you online? Can we hear you?
I'm online. Good afternoon.
Good afternoon. Nice to see you. The floor is yours. Thank you.
Very good. I just need to find share. Here we go. So hopefully you can see the screen. So good afternoon, everybody. I'm Scott Hansen from the Open Group. Welcome to the MedSecurance webinar. Today we're going to share with you two of our tools that have been developed within the MedSecurance project. Give you a little bit of a demonstration and show you the kind of capabilities that the tools provide for medical device manufacturers, as well as for hospital and healthcare providers. Just to give you a quick introduction to the project, it's an EU-funded project. It's been running for 3 years. It was driven by the needs and the awareness of the risks and additional security threats that are being posed by having more and more connected medical devices. So we were experiencing quite strong trends with the Internet of Things, and what we were seeing in the medical domain was the Internet of Medical Things. And more devices were being connected, creating more and more opportunities for bad actors, but also further challenges with respect to assurance and making sure that medical devices could be certified as being safe and dependable. So the project was really formed to address those challenges of how do you actually improve the security and the assurance of medical devices. And the target and the work that was done within the project was to introduce new methodologies, technologies, as well as recommendations for new standards to allow for better development and evolution of secure and safe Internet of Medical Things. The project objectives, we've been running for 3 years, and the objectives focused on first understanding and carrying out a gap analysis, the various security approaches that are used for Internet of Medical Devices, Internet of Medical Things, IoMT, and to understand what's being applied and what are some of the risks and the vulnerabilities with some of the methods that are being used and where can they be improved. We spent most of the work in the project developing harmonized tools and methods and unified security and safety assurance capabilities that allow you to map amongst the different standards and certification regimes depending on the typical devices and where they're being applied. And we've created a security assurance automation toolbox that has a set of tools that enables medical device manufacturers as well as providers of medical service systems, hospitals, healthcare systems to improve and better manage the security vulnerabilities and risks and to mitigate those risks, and also to automate the assurance process where certification are required for systems and devices. We're going to show you today 2 of those tools, but there's a further set of tools that we'll be sharing in further webinars. It's also available on the project website. We've also been driven in the project by a set of industry organizations that have identified the requirements early on in the projects, have carried out evaluations at the midway of the project, and have just completed the industrial evaluations of the tools that we're going to show today, as well as the other tools within the security assurance automation toolbox. We've also been looking at the MDCG guidelines in terms of certification and compliance, and we have identified a set of recommendations for improving those guidelines, some updates that both improve the methods and the techniques, but also updates that exploit the new technologies and capabilities that can be applied during development as well as during the certification process, and some of the automation capabilities that are now available based on the results from the project. All of the project results are available in open source, so everything that you're going to see demonstrated today is accessible, is available, and can be accessed in open source from the GitHub repos, which we're happy to share with you. Project partners in the MedSecurance project included a set of research and development partners from University of Warwick, University of Birmingham in the UK, Polytechnical University in Catalonia, the European University in Cyprus, CEA, which is a very large research organization in France, the Open Group, which is my organization. We're a standards organization, but we also develop reference technologies for industry. And the project was coordinated by an SME organization that delivers technology, unparalleled innovation. The industry partners included Hygia Hospital and Hospital Garcia de Orda in Greece and in Portugal. We also had equipment providers, medical device providers with StatVita, and systems providers with BioAssist, and DACA provides remote patient monitoring and care services. They're the industry partners that have helped with the requirements and defining what's needed and also in the evaluations. And supporting all of our activities throughout the project, and the organization that has helped organize this webinar is EFMI, the European Federation of Medical Informatics, represented and supported by their many members who have helped us with stakeholder engagement in creating awareness of the technologies and also guiding us in terms of the certification and regulatory activities. So that's a brief introduction to MedSecurance. I don't want to spend too much time with introductions, but just to give you a quick overview of what the project is about and get into the actual tool demonstrations. So presenting today, we'll be showing you the Threat Vulnerability Risk Analysis Toolkit, TVRA we call it. And the presenter will be Mahendra Kumar from the University of Warwick, who's been the lead developer in creating the tool with the team at the university there. And we'll spend about 30 minutes looking and demonstrating that tool. And then we'll ask Kostas Iordanou to share the IoMT communication recommendation tools, ICRT. And Kostas is from the University of Cyprus and has also been leading the development of the tool work there. So we have our lead tool developers here to demonstrate the tools for you. And we should have about 10 minutes left for a Q&A session for any questions you might have about the tools and accessibility and any other questions you might have about the project. So with that as an introduction, I think we can move right into the first tool and turn over to Mahendra Kumar to share with you and introduce the Threat Vulnerability Risk Analysis tool, the TVRA toolkit.
Thank you so much, Scott. Am I audible?
We can hear you.
Yeah, thank you. Let me share my screen first and then. Just to confirm, screen is visible to all?
We can see it, but you're in edit mode.
Thank you. Thank you so much. So, good afternoon. And today I'm going to present the first, the important tool of MedSecurance, which is the TVRA. Basically, the full form of TVRA is Threat Vulnerability and Risk Assessment. And I'm Mahendra Kumar, and I'm a research fellow in University of Warwick. So the agenda for my slides is first I will present the TVRA introduction and then what it's all about and why it matters in medical domain and what's the architecture and core component of TVRA, and then I will show the TVRA demonstration and some validation from use case partner. So what is TVRA? Actually, it is a unified security automation platform, which is modular driven and API toolkit for to provide or to save the end-to-end IoMT security analysis, and it connects the engineering design to live security assurance, and as an output, it gives an actionable race for users attack patterns to understand or to visualize how attacks is going from within the IoMT network, and it also gives the compliance ready evidence so that user or you can say manufacturer they can have some information about information about the evidence the TVRA is compliant with ISO 27001 and other standards. So this is a basic architecture of TVRA, which is where you can see in image. So basically, it has four main components. The core component is IoMT vulnerability scanner. The role of a vulnerability scanner is to scan the IoMT network and uh, identify the threats and vulnerability within the IoMT network. And for vulnerability scan, we are using an open source tool, which is the OpenVest for medical devices and network scanning. And it tools give some idea about the vulnerabilities and threats, but we find like some of the threats are, or you can say vulnerability that are latent, that that are not identified by vulnerability scanner. So we have another component in TVRA, which is a threat modeling companion, and which is the AI powered tool for to identify or to monitor the IoMT network and identify threats and detect them and provide the mitigation strategy for other tool within the MedSecurance project. Other tool is the next tool is the attack path visualizer. It is a kind of graph-based system, so that user, or you can say a developer, I mean use case partner within our MedSecurance project, they can have an idea like what are the patterns within the IoMT network they are using, and they can have some wild information for this by using the attack path. So if a user can have this kind of information, so they can predict or they can visualize attack paths by using this tool. And the last tool is the risk engine, where we use the spider risk, which is developed by the University of Southampton, which is uh, and we parameterized some attributes in spider risk in order to identify which in order to assess risk associated with threats within the network system. So this tool have two main uses mode. So user partner or manufacturer vendor, they can use is at as a scanner standalone. So in first user mode, they can use it as a vulnerability scanner, which is a single-handed tool. And the advantage of this user mode in this mode, this is quick and focused report. So the user have some information about the vulnerability within their use case scenario. And the other uses mode is the risk management. In this mode, we have the scannable, I mean, vulnerability scanner plus risk engine supported by Spider Risk. So it is a full risk modeling, which gives the end-to-end assessment flow workflow to the user, and it gives the recommendation for, I mean, for compliances and assurance as well. So for risk assessment within the TVRA, so this is a model-driven architecture. So how we assess the risk? So we have a risk assessment framework. So the information is getting from the another tool, which is the IoMT engineering tool. So we get the JSON file within JSON file, including the vulnerability and threats, and we use a spider risk as a tool to automate threat detection and to score the risk associated with threats. So how this framework will work? So we categorize the risk associated with threats within the network in 5 different levels. So the severe level is the critical. If the immediate action required, then we call it as a critical risk. And as likewise, we have the high risk that address the promptly, and the medium, low, and negligible. That means there is a chance to accept the risk. So that means we are neglecting the risk. So this way we have a five level of risk associated with the TVRA, and how we calculate or assess the risk is based upon the vulnerability severity, threat likelihood, how frequent the threat is occur within the scenario, and the asset importance. Asset in the sense is the device. You can say a medical device, router, or the connection between the two devices. So how important the asset is. So we consider this as a factor while considering the risk calculation. And other factor is attack complexity, and the last is the potential impact. How impactful is the the risk is. So this is the way how we assess the risk associated with IoMT network. Um, in addition, we have threat modeling, which is support to the vulnerability scanner. Those vulnerability or threats which are not identified the previous tool. So we have the threat modeling. So University of Birmingham, they developed this tool, which is they are supporting us. So this tool is a AI-driven detection as well as the mitigation generation. So they use the fine-tuned GPT, which is the LLM model, which is trained on the medical IoT threats, and they detect the threat beyond standard database like MITRE or CV. And this information is context aware, which are not identified, or you can say latent information within the network. And for mitigation generation, they provide the information to recommend specific countermeasure per threat. And this tool is aligned with the ISO 27001 as a standard. uh, in order to see like how this tool is interoperable with or you can say integrate with other tool within the MedSecurance is, so the tool is integrated with the MedSecurance ecosystem. So TVRA is connected with the IoMT model based engineering tool, where CEA is working on. They developed this tool. So this is a tool is as a system architecture modeler. So they model this architecture, and we import the information they gave us as an output. The next tool is the ontology tool, which is a security knowledge base. So they provide the access threat ontologies. So the TVR is also integrated with the ontology tool, and the TVR is also integrated with the communication recommendation tool, which is a kind of communication advisor, and they recommend the secure protocol. And the last one is the assurance tool, which is the assurance case manager, and that will responsible for managing the assurance. So they generate the compliance evidence. So the TVR is also integrated with the assurance tool as well. So all these tools via standardized REST API and JSON files we have that will support the integration. So we can say like the TVR is seamless interoperable. Okay, so as an output, TVRA is giving flexible reporting formats. So for human readable format, we have the interactive HTML reports, so that user or the human can have, so they can get information quickly. So we have the interactive HTML reports, visual attack path diagram in SVG format, and some executive summaries to make them understand. And other information to make machine readable, we have structured JSON for automation, integration ready data formats, and evidence for audit trails that is support to the uh, assurance tool. So this tool enables both expert view and pipeline integration as well. So this is some APIs, which is TVRA is providing to manufacturers so that they can use this API to use TVRA. So if they want to scan the new scan, so we have API. And to monitor, they have different API. And for scan result, we have different JSON format, JSON and HTML format APIs. So in demonstration, you will get the idea how this tool will work. So I will share the demo. I have a video recorded. Uh, Let me know if you can listen Mirek voice. Otherwise, I can mimic him.
No, Mahenda, we cannot hear the voice of the video.
Okay.
I think there is an option when you do the share screen that you can choose also to share video. So you might stop sharing and then share again and
Okay.
check if there is an option. Otherwise, you can do the speaking.
Okay, I can check. Can you confirm, Paris?
No, we still do not hear the video. So
Okay.
can you do the presentation?
I think I shared the video.
Yeah, we can see the video. We cannot hear
Okay.
the voice on the video. So you might do the presentation.
How can I do this?
Sorry, you might speak during the video playback to present and what the video demonstrates.
I can't see. Actually, okay. So you mean I go to the video and there I share the video on Zoom. Am I right?
Yeah, the video is fine. We can see the video now. Just
Okay.
speak and do the presentation. Speak.
Okay. 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 Okay, so in this demo, Mirek is first giving you a brief idea how TVRA is and what is TVRA. That is I already show you. So I will give you. I will go to the appropriate portion. Okay, so he's talking about like that there is a API like report, scan, thread. So first he will go to the scan part. So this is the research part. So in this way, you have to select the test name, and it will after executing, he will give the scan ID. So in background, the scanning is done and it will generate some scan ID. And in order to generate the report, you have to go to, so in parallel, they generate some attack patterns path. And this is the information about the vulnerability assessment report. And this is the information is in JSON format so that machine can understand better. So the another part is the system modeling. So for system modeling, you have to first design the system architecture in spider risk. Yeah, so he just extract the file in JSON format and then execute it. So it will generate the model ID, and this model ID will go to the threat API. So after executing, so they give the information about the risk assessment, and all the information within this file. You can see like they give the threats attributes like how this vulnerability is about description. They threaten asset likelihood value, like either they are very high critical, and their description expected within minute, and risk level. So so it will give the information about the threats and the risk level. So after getting the information about the risk and risk level, so the next task is to for the recommendation. So for this model ID, model ID they will give to the next API, which is a recommendation or mitigation, and the tool will recommend you about the recommendation. Uh, so they give the information of the risk and the consequences and the recommendation. For this particular for this particular case, the recommendation is null. So the last tool is the attack path generation. So it generates this attack paths. So this is the visualization how it will help to the manufacturer, use case partner to identify how this attack will go from one point to the another point. Now he demonstrate how this the tool is working behind with the Docker. So this is a small backend architecture with architecture of TVRA, and how the workflow between the scanning, threat analysis, and how the component workflow will going on. Yeah, uh, this is all for the demonstration, and I will share my screen again for the last part of the presentation. Mm, So this is the use case architecture for remote patient monitoring system. So this is a high-level architecture, how the IoMT modeling will, how this IoMT model, the architecture. So you can see on the left side, there is a patient monitoring device which is connected with the patient, and the patient data is through his personal assistant device go to the network, and this network is connected with the health provider and the third-party services through router, cloud central data repository, and the data processing analysts. So this is the high-level architecture. So for tool validation, our TVRA tool validated with three major medical use cases. The first one is a remote patient monitoring, which is conducted by the bioassistant Hygia hospital. The second one is the portable lab testing, and which is conducted by the Stavida and HGO hospital. And the last one is the virtual hospital conducted by Dokula. So all partners confirm like TVRA made the systems more secure without showing down the innovation. So this is from my side. If you have any question, you can ask me.
Thank you, Mahenda. Well, maybe we can discuss a little bit later during the Q&A session. And now we can proceed on the next presentation by Kostas Iordanou. Thank you.
Thanks, Barry. Let me share my screen. Now you should be able to see my presentation, correct?
Yep.
Okay, so thanks, Paris, for the introduction. My name is Kostas Iordanou. I'm an assistant professor at the European University Cyprus, and I'm leading the development of the IoMT communication recommendation tools, or in short, ICRT, part of the MedSecurance framework. So first, let me also welcome you to the MedSecurance first webinar. So from my side, the purpose of this presentation is to introduce the IoMT communication recommendation tools and its value for secure IoMT deployment. My short agenda includes the tool objectives, the high-level architecture of our tools, some key features and short demos of the tools, and finally a tool validation based on the use case scenarios of our use case partners. So with respect to the tool objectives, first we need to detect protocol level vulnerabilities, audit device compliance with safety and security standards, recommend protocol-specific mitigation based on our findings and the user inputs into our tools. We can also do runtime anomaly detection with a couple of tools that monitor the network and inform the user about any anomalies. And finally, we provide dedicated access control management through a tool that is aggregating all the devices connected on a specific network under examination. This is the high-level architecture of the tools in a simplified format, of course, to be able to go over them. Basically, we have 6 main components. First, we have the authenticator that is wrapping all the other tools, and it provides multi-factor authentication, role-based access control, and auditable login history. Later on, we will see all these functionalities in action during the demos. Then the second tool is the device manager. It's a central inventory of all the connected IoMT devices within a network that the user can define. It provides CRUD API for adding, removing, updating, deleting devices within the different networks, and also tracks firmware capabilities and protocol stacks of the different devices that the users define in the device manager. Next, we have, let's say, a group of tools that they are dedicated to monitoring the intrusion detection system, or IDS in short, and the monitor matrix. Both tools provide real-time traffic analysis and logging. They can be used for anomaly detection and monitoring the total devices, the data transfer, and the event counts of the devices connected to a specific network. Again, we'll see them in action in a few minutes. Next, we have the protocol evaluator, which is part of the protocol analysis stack. It provides automated protocol scanning. It checks against different standard guidelines related to IoMT communication protocols, and it generates compliance and risk scores reports when it's integrated with the assurance tool that we also mentioned in our previous presentation. Next, we have the mitigator, which is responsible to generate mitigation plans tailored to devices and protocols based on what the user defines during the utilization of the tools. I will switch to the tool demos. First, I'm going to present the device manager and the risk assessment tool. In the architecture, we define them as protocol evaluator and mitigator. Again, it's a pre-recorded video. I also have a live deployment. If we have some time, maybe we can play a little bit with the live deployment that I have on my computer. So this is the graphical interface. We have the basic components here at the left side: the risk assessment, the device manager, the admin config panel, and the activity log. We'll go over them during the video playback. So let me start the video. There is no audio, so I will comment. So we'll start with the device manager. We can create individual devices here. We have different options for the user to fill up and supported communication protocols. But for simplicity now, I'm going to use the import functionality to import 5 devices to save some time. We can see the devices here that we have for our testing. We can click on those and alter any values that we may need to change. We need some basic information in order to identify the device and understand the capabilities of the device, so we can provide recommendations later on based on the network configuration. So for a risk assessment, we are supporting currently 4 protocols: Wi-Fi, Bluetooth, GSM, and LoRaWAN. Again, for simplicity, I will upload a scenario that we already filled before. This is related to Wi-Fi. We can define some parameters. Intentionally here, let me pause a little bit the video. So intentionally here, we leave all these options unchecked. Basically, here, the network administrator needs to define here the checkboxes, need to click the checkboxes if all these security measures are actually deployed. If not, then they need to leave empty, and then based on the setup and the configuration of the network, we can start recommending the user to deploy such services. And of course, if those services are deployed, then the recommendations will disappear, as I will show later on during the demo. Here we can define the access points. Since we have a Wi-Fi network, we can have multiple of those. Here we can keep some records about the network health status and how frequently they have failures. And also with this button, this is an optional in case the user already utilizes the TVRA tool that we saw before. they can upload the report that they receive from TVRA, and we can enhance our recommendations based on the findings of TVRA as well. So in case you have the TVRA output and you don't want to check it manually, you can upload it on this tool, and we can aggregate the results with the results of our tool as well. In this case, I receive 5 outputs from TVRA. And if I click finish, now I will process the configuration, the devices, their capabilities, and I will provide the recommendations. We have different categories. First, we have the mitigations. We have safe configuration recommendations, protocol replacement, if it's possible, and vulnerabilities which are related to the TVRA. Notice that we have different, let me go back a little bit. We have numbers at the beginning. Basically, we weight the recommendations based on their importance. 5, we consider them as critical. And as we go lower numbers, then less critical. And we also use coloring. Criticals are red, and then we move to different colors so that the user can easily spot what is the important things that they need to pay attention and fix them as soon as possible. So in this case, I assume that the network administrator managed to deploy an intrusion detection system, so it can come back and update the configuration and reanalyze the configuration. And as we see here, now the first mitigation has been removed. We can do the same for firewall now. We can enable firewall in our access points and routers, and then we can rerun the analysis, and we can see now in the safe configuration that firewall warnings has been removed. Next, in the admin configuration panel, we allow the organizations to define 3 variables that they can give you the status of your organization with respect to response time and ability to recover from network failures. First, we have the mean downtime in minutes, the lifetime in years, to capture how old is your network. For example, if you set this to 3 years, then you will start getting warnings that your network is old and you need to maintain it, update devices, check firmwares, and so on. And finally, we have mean time to repair in minutes, which captures the response time of your organization to recover from network failures. In this case, I will alter one of these values. So we provide this flexibility for the organization to define their own constraints with respect to this kind of failures. And the last one is the activity log. If I move to the last records, you will see the activities that we did during the demo. We update the configuration. We run a couple of risk assessments. We add some devices here, and so on. And of course, you can use that in case of an incident to see who did what on the system. The next demo is a monitor matrix tool. Let me start it so we can have something to discuss. So let me stop it here. So this tool, basically, you need to deploy it on the network that you want to scan. In this case, I have a local test network that I'm testing and debugging the tools. Basically, those 2 are actual devices in my network. This is my solar inverter, and this is my personal computer that I'm running at home, and of course some demo devices that are deployed. So what it's doing is monitoring the range of IPs in your network. and it detects any devices that are available, and it can monitor the traffic of your device and detect in which domains is communicating. Let me continue the playback. So basically, the device list is showing all the devices in your network. In case you have devices that are not defined in the device manager on the previous tool that I demo, then you will start receiving emails that you have unknown devices in your network. So imagine a scenario where you are in a hospital, you have some IoMT devices that are monitoring your patients, and then for some reason, some of the visitors or some of the patients, they manage to connect to your intensive care network with their devices. The tool will be able to detect such cases and report back to the network administrator. Next, we have the overview, which basically allows you to define the time window that you want to see the network activity of the devices. First, we have some graphs showing the traffic, and then we can see the domain names that the traffic is directed to and which devices are communicating with such domains. The other option is to switch to countries. Let me pause it here. So what we are doing here, we are collecting the IPs of the servers that the device is communicating with, and then we use geolocation services to translate the IPs to the physical location of the machines. For example, if you want to know if, let's say, an IoT device that you bought is sending any data to the Chinese manufacturer that was not supposed to happening, then you will be able to figure it out from here. If you don't know the domains, maybe you can understand that the country is not a country that your device was supposed to communicate with. And of course, in my case now, we have a lot of traffic because I'm using a normal computer, so I'm visiting a lot of websites. Actually, here we can see the traffic only from my personal PC. You need some time to do the analysis depending on how heavy the device is. And by the way, in an IoMT environment, we are not expecting to have so much traffic for any device, so it's going to be very, very fast. Actually, the next example is really nice. I'm going to check my Huawei inverter to make sure that it's actually only communicating with the local European server that is collecting the statistics. And if we go down, we will see that we are actually only communicating with oragebusiness.com, which is the company handling the Huawei traffic here in Europe. We can export the data in a CSV format for easy digestion by other applications. And of course, we can export in a human readable format by using the print functionality of the browser. Straightforward, you get everything listed as shown in the screen. And of course, we can quit the application because it's generating traffic on the network to be able to monitor the devices. So usually you use this tool for new devices just to make sure that they work as expected, and then periodically you just check if everything is okay on the network. And the last demo, it's the intrusion detection system, or in short, IDS. This is a much simpler tool. It's just a simple HTML website that you can upload your network traces in a pickup file. And then we have two different AI models that analyze the network trace. And the first model is try to identify if there is any attack traces in the network traffic. And if yes, then we have a second classifier that try to identify the type of the attack that was detected. The idea behind this simple implementation is that as a first attempt to introduce IDS in medical environments, we didn't want to mess with the actual hospital network. So in a production, in a final state, instead of uploading the files manually, we can provide an API endpoint that accepts network traces stream, and then we can analyze the stream data in real time instead of uploading files, static files. Let's move on with the demo. First, we need to upload our network trace file in the pickup format. Then if we start the process, then we can analyze the file in real time, generate some features in a CSV format, and then pass it to the two classifiers. So the first column provides the probability of finding an attack. In this case, we have an attack. And if we check the second classifier, we see that with 100% probability, this traffic between these two MAC addresses was web-based attack. If we check the second one, here we have a 0.9 probability of an attack. And in this case, the highest probability is for a recon, and we logged it here for the user. Of course, you can expand and download the output in a CSV format. And finally, as you see at the bottom, in this case, we did an attack. We record the file name that was uploaded, and we send an email to the network administrator informing about the attack that was detected. Of course, we can reset the interface and upload another file and repeat the process. So for the last part of the presentation, I collect some information about the tool validation from the use case partners, BioAssist, Dokla, Garcia de Horta, Stab Vida, and IA Hospital in Greece. So the ICRT tool was used in scenarios involving IoMT communication protocol risk analysis from all these organizations, interoperability and integration evaluation with hospital systems by the two hospitals partners, third-party device integration with existing systems, security and vulnerability assets related to device communication interfaces, and finally, for device inventorying and communication parameters management through the device manager. From the brief feedback that we received, the ICRT value across the scenarios was its ability to analyze communication performance and security risks, provide secure configuration recommendations to its users, validate interoperability and secure data exchange between devices and ingestion systems in a production environment, and support integration workflow in controlled and clinical environment. Of course, the tools are still under evaluation by the use case partners, so we are expecting to receive more feedback. And with that, I'm done with my presentation. If we have some time, we'd like also to show a little bit, because it's a lot of tools, to share our current GitHub repository. Everything is named in a convenient way so you can understand which tool is located in which place. We also provide details of the functionalities of each of the tools, the installation process, how to deploy it for local development if you want to change something, how you can deploy them in a production environment, the different variables that you can play with to achieve the appropriate setup and have all the functionality working as expected. And of course, we provide a detailed user manual and installation manual, which is located also in the repository. It's over here. So it's, I think, straightforward for, although it looks complicated, it's straightforward on how to set it up and test it yourself. And with that, I think I'm done with my presentation.
Very good. Thanks very much, Kostas.